introduce Mr. Raleigh Catani. He is a solutions architect with Contrast Security. He has a background in software development. He's worked on SAST, IAST, and RASP technologies, and I have no idea what any of those are. He holds a master's degree in management information systems from GW and a bachelor's degree in computer science from Georgia College. So he is here to talk about the vulnerability management and software security. So without further ado, give a hand for Raleigh.
Hey guys, thank you for your time today, and thanks for the invite. Today I'm going to talk about the technology that Contrast Security actually does, and specifically how different organizations are actually jump-starting their DevSecOps pipeline with IAST and RASP. So applications right now are the top number one breach vector in the world. As you can see, we hear about different organizations getting hacked on a monthly basis. A lot of times it's through vulnerability inside their app. But only 10% actually of applications are actually secured, and they have around 27 vulnerabilities. Software is around 37% of enterprise IT spend, but only 2% is actually spent on security. So it's really important. Application security is very important for different organizations, and they should spend more time and more money on it. This is the evolution of the AppSec automation actually. So back in 2002, different organizations were fixing vulnerabilities in applications through static analysis or even dynamic analysis, which were good back then, but they were focused on frameworks and technologies in the years back then. And then there's, in the year 2012, there's IAST, which stands for Interactive Application Security Testing. And then in operations field, we have WAF, as well as IDS and IPS that were back in 2002, and you have the RASP technology, which stands for the Runtime Application Self-Protection. And then today, we have different organizations that are opting for a unified solution that is IAST and RASP, as well as CA, which is Software Composition Analysis, and this is where Contrast Security actually fits in. How does it work? So you have the application stack here, and all you do, you just install the agent, and then with a simple tag, and then what it does, it actually places different sensors within your application. And think about these sensors like a set of security cameras that you would have inside your building. So you can have security camera in the parking lot, in the elevator, in different meeting rooms, and then when someone comes through your building, you can follow that person, and you can see if that person is dangerous. We work the exact same way, and we work on normal traffic. So basically on test data, and we work in parallel when your app is actually working. And then when we find vulnerabilities or attacks, we actually send them over to the dashboard. And the dashboard is, of course, available on premise or on the cloud. Now, how does IAST and RASP really work? So as I mentioned, you have these different sensors. And then when you are working normally with your app, with normal test data, then the IAST comes in and detects vulnerabilities or and sees or watches different data flow through the app until vulnerability is actually confirmed. If you don't have time to fix your vulnerability, then you can actually enable the protection agent with the same agent actually, you can enable the protection capability that actually will follow dangerous data with the same sensors and actually block different attacks before they're actually exploiting the app. Now, why do different organizations choose the IAST? The IAST actually, it's because it's way more accurate. Different SAST or DAST technologies, for example, for SAST, they look only through source code, so they actually miss different calls that are going through the different open source libraries or even closed source libraries. They also have issues with different API calls, okay? And then finally, because they were designed for applications that are written back in 2005 and so forth, they don't see vulnerabilities in dynamically loaded code or inversion control in frameworks or dependency injection. And this is where the IAST technology is extremely more accurate. It's also continuous, which means that as soon as you find a vulnerability, you can find the vulnerability right away. So there's quick notifications that can happen through email or chat ops and so forth. This also enables different organizations to completely shift left. And what I mean by that is they allow their developers to test their code as soon as they're writing code. They can find vulnerabilities and right when they're writing code. So they don't need to wait for a scan to finish and so forth. They can, of course, fail builds. The IAST technology is also very integrated, so there's integrations with IDE, CI/CD, build platforms, and so forth. And then finally, our solution actually is very distributed, means if you have, like, let's say 100 apps, you don't need to wait for these 100 apps to finish scanning. All you need to do is just onboard these 100 apps with different agents, and you can find vulnerabilities in real time, all of them in one dashboard. Now, how does our solution scale, or how do we allow different organizations to also automate security? So first of all, in the development stage, we allow different developers to find vulnerabilities right in their IDE, whether it's Eclipse, Visual Studio, or IntelliJ. They're able to find vulnerabilities right in their IDE, and then when they click on the IDE or in the vulnerability, they can find exactly in the code where they need to fix their vulnerability. There's also Slack and HipChat integration. For CI/CD, we have different integrations with Jenkins as well as Bamboo, so you can easily fail the build. For the QA, you can find vulnerabilities and you can send them over to Jira, Bugzilla, as well as PSTS. And we also have two-way integration with these tools, allowing your developers to see vulnerabilities in these bug tracking software. Then when they fix vulnerabilities in these bug tracking software, they can these vulnerabilities can go back to the dashboard and be fixed. And then finally, when you don't have time to fix your vulnerabilities, you're actually you can enable the SIEM tools, or you can enable our data to go to SIEM tools, whether you're actually monitoring different attacks or blocking different attacks, right? Anything that happens in the production environment, you can actually send it over to SIEM tools. Okay, any questions? I think it did in like 10 minutes. Tom? Yes?
Typically, how long from start to finish does it take to begin do a project like this?
How long does it take from start to finish to implement a product like this? Or how long does it take to find vulnerabilities?
To implement the product.
So usually the implementation takes around, 5 minutes or so to onboard an agent inside an app. And then when the app is running with normal traffic, when end users just use your app, they're finding vulnerabilities right away. Well, not they, but you would find vulnerabilities right away within seconds. So we don't work, we're not a scanning technology, we're more of a monitoring technology that finds results within seconds.
You, as an individual, have been in this space for a long time in application security. Where do you think it's going? What's the next what's the killer vulnerability? Like where's the threat landscape going? And where do you think the industry's gonna go to counter that?
Absolutely. So let me give you a little history, right? Back in 2000, 2005, people started with static analysis, right? Or actually they started with DAST. They said, well, we need to find vulnerabilities and are running out, right?
Pen
It was
testing, essentially.
pen testing initially, right? And you have different tools that are trying to attack or penetrate the app. That was an excellent idea, except that first it breaks different apps. It sends data, wrong data to the production data. So that, and then also it doesn't tell the developers where the vulnerability really is in the source code. And third, even if it tells the developers that there's a vulnerability like SQL injection or cross-site script and whatnot in a specific page, it takes so long to go back to the code, fix it, run through the testing and whatnot. And this is where static analysis came, and they said, well, you don't need to wait until the application is actually working, right? You can scan the source code and fix or find vulnerabilities, and we'll tell you exactly where in the code. That's also very good, except that back in 2000, it was focused on frameworks and technologies from back then. Now, with the latest technologies like inversion and control or frameworks and different things, static analysis have had a hard time finding vulnerabilities because sometimes there are some applications that are grabbing different classes or codes or source codes and so forth when the application is running. No SaaS tool will be able to find vulnerabilities that are present in these type of frameworks. So, and when you see the landscape now, a lot of static analysis tools right now, they're actually are moving into the IaaS, the concept of IaaS, which is what we do. And so we're actually revolutionizing the market, right? I used to be in the SaaS market before joining Contrast, so I see a lot of different organizations moving into that field as well. So I think it's going to be the future where different organizations are moving from the scanning concept, okay, into the monitoring concept. And the reason is, again, accuracy, but then also or speed. They don't need to click a button on Launch a Scan and wait for an hour or two or even more to find vulnerabilities. They can just visit one page, right? Anyone can visit one page, click on one button, and they will find vulnerability in a second, as opposed to scanning the whole app. So, because also the different organizations are moving to DevSecOps, okay, or DevOps, but they want to include security as well. So that's where things are moving.
If I can follow up with, so how does that work with microservices? How do you install the agent? Like
So
Microsoft?
if a microservice, right now, the way our company does IaaS, if the microservice is available as a web service, so you can just enable or onboard that microservice as well. In other words, if you have like one app that's talking to 10 microservices, then you will need to onboard these 10 microservices as well. If these microservices are, for example, in IaaS, then all you need to do is install one agent that looks at the whole IaaS, finds all the different microservices and finds vulnerabilities and all of that.
Does anybody have any more questions for Raleigh? Well, here's your chance to stump him. All right,
Thank
Raleigh,
you.
thank you so much. Next up is Josh Stella from Feud. We'll do a brief bio here while he sets up. I can tap hands too if it takes longer to set up. He's the co-founder and CTO of Feud. Previously, he was a principal security solutions architect at Amazon Web Services, where he supported national security customers. Not to kill you if he tells you do. He has served as CTO for a technology startup and in numerous other technology IT leadership roles over the past 25 years. You don't look it, Josh.
Yeah, it's been a while.
All right.
Let's see, I've got,
And
see if I can
please
figure out
welcome
how to
Josh
mirror
Stella.
my displays. Thank you.
Are you in night mode?
I'm sorry?
You must be in night mode.
No, it's just decided that rather than mirroring displays, it would extend them. So let me see. Fix that real quick. Mirror displays. Okay. So thanks for the introduction and thanks for the time to talk to you. I did come from Amazon Web Services prior to founding Fugue. Prior to that, I worked in kind of in and out of startups and national security and federal space. So I'm kind of 1 foot in the federal world and 1 foot in the startup world and have been for a long time. Can I just get a show of hands? How many people are actively using public cloud? Anyone? All right, great. So of you who are actively using public cloud, how many are confident that when you deployed your infrastructure, it was, for example, NIST compliant and correct? All right, then.
When we started, it was correct.
Thank you. That was going to be my next question, but I didn't have any hands left up. So there's this whole new class of problems on cloud. And I saw it over and again at AWS, and we deal with it every day. So what Fugue is about is cloud infrastructure, automation, and security. I'm not going to give you a Fugue pitch. I'm going to talk about the problem, and then at the end I'm going to tell you a little bit about exactly how we solve it. So the cloud creates new challenges. You have now API-driven infrastructure. So in the past, when you had data centers, you'd have a change control board, right? You'd say, we're going to deploy this new firewall, we're going to run a new network route, we're going to deploy a new VLAN, and people would go through an Excel spreadsheet or something similar, or if you're unlucky, BMC's interface, and you would make decisions about what was going to happen in the infrastructure. And those would often take weeks or months. And so you had a lot of time and friction that we kind of took for granted. In fact, it made us frustrated, right? I just want my stuff now. Well, cloud gives you stuff now. It's API driven, right? You're milliseconds away from an entire new network, right? You just deploy a VPC. Any developer in your organization can do that. What you end up with are a lot of moving parts, and the configurations are really easy to get wrong because the cloud has so many features. So I'm an AWS alum. I love AWS. I think Azure's really cool. I like what Google's doing. But all the capability they're giving you is also opportunity for error. In addition to that, in the data center, you tended to think about a relatively small number of kinds of things, meaning infrastructure. Compute servers, whether blades or whatever flavor of them, but you had compute, network, storage, some security appliances. You might be able to count on fingers and toes, but it was a constrained number. AWS alone now has over 120 different services. So when you think about infrastructure now, we think about infrastructure as a service. Well, what's Lambda? Right? Lambda is functions as a service, things we used to think of as being contained inside these compute devices, and infrastructure was about controlling the compute devices. I'm going to take an aside here and say, your security folks, infrastructure configuration is the largest attack surface on the cloud, by far. Gartner says 80 to 90% of exploits on cloud, of breaches of cloud, are due to misconfiguration of cloud infrastructure. So this is the new, future shock. There is a future shock aspect to this. Because in a single cloud deployment of a system, you probably will have hundreds to low thousands of cloud resources, things like S3 buckets, EC2 servers, subnet configurations, etc. And every one of those can be configured in many, many ways. That is the new attack surface as you move to public cloud. The other ones still exist, but that's the dominant one. And that means, as security professionals, you have this whole new area to worry about. And so this sprawl of services, many more new things. Lambda, this year, watch every reInvent. Every time Azure announces new features, it's dozens a year of new things to have to know how to configure correctly for them to be secure. And what this leads to is a loss of control at scale. So I was talking to a customer today who have, according to our count, we were working with them doing some deployment, and we got up to about 250,000 configuration objects, right? That's after 2 years on the cloud. So these are things, again, like firewall port configuration rules, routing tables, et cetera, all this stuff. So the problem is bad up front. You have to know how to get everything right. And then as you build more, it gets worse because you've left this trail of stuff behind you that is now growing. And guess what? It's all still API-driven infrastructure, so people are changing it. So this is the new reality on cloud. So the current methods are just not good enough. Scan and report tools, they generate alerts after the fact. Worse than that, they generate tons of false positives. So if you're just building stuff on cloud and then counting on some security scanning tool to go look at it and tell you where the threats are, it's going to do two things. One, it's going to be way too slow. And two, it's going to drown you in a bunch of things that you may or may not care about to find the ones you really do. So usually people then go to, well, I'll just blacklist, I'll just shut things off on the cloud. Right? I'll keep my people from being able to do this list of things. If any of you have kids, telling your kids everything they're not allowed to do is impossible. Right? They're clever. They find ways around it. So you do two bad things with blacklisting. One is you keep your developers from innovating. Right? You say, nope, can't use Lambda, haven't looked at it yet. We're gonna block you off of that. And two, when you go home at night, you think about, when am I going to worry about getting a page in the morning? And it's going to be something you missed in the list of things to say no to. You're never going to be complete in a blacklist. So it's just not good enough. And then finally, we're used to, as security professionals, having to click on buttons to actually fix things. Manual remediation, right? An alert goes up, it gets looked at by somebody, and that human being then goes and makes a decision about how to fix it. That's just far too slow in the cloud. And the reason is your exposure is huge. So these are just a few headlines over the last year or so of what on cloud is a really simple misconfiguration. It's just a misconfiguration, what's called an S3 bucket, right? So lock your doors, Verizon breach on unsecured AWS. They say server, it wasn't, it was an S3 bucket. Exposes 14 million customer records, right? So if you're using cloud and you've got, I talked about a customer with over 250,000 configuration items, any one of which can result in that headline. So this is the problem. So I think the goal should be to create self-healing cloud environments. I think this is how it should work. And what I mean by that, and let me check my slides here. I'm just going to talk to this one for a little while. So the first thing you need to be able to do is when you build something on cloud, know if you're getting it right. So I'll talk a little bit about our approach to this. I promise not to be a vendor pitch, but this is how we approach it. Feud contains a library of code that describes all of NIST 800-53 as it relates to cloud infrastructure. It also contains GDPR or HIPAA, and you can ask Feud prior to deployment, is this compliant with NIST 800-53? And if it's not, it refuses to deploy. So that's upfront getting it right, but that's not nearly good enough, because once you've deployed it, people can go and change it, and that's why it needs to be self-healing. So what we mean by that is anytime something changes in the environment from that known good baseline that you established up front, it gets fixed automatically, usually within a minute. At least that's our view of the world. You can also ask our software just to tell you when something's wrong. But the way I think we should do this as an industry is trust algorithms. We're not talking about detecting intruders, things that are hard to get right. We're talking about, we know that S3 bucket should not be open to the world. And if somebody goes in and opens it to the world, Feud can revert it. So this self-healing cloud environment allows you to only actually change the infrastructure in a permanent way through a controlled process. It's a much faster controlled process than in the bad old days of requisitioning a firewall and having it shipped and wheeling it out onto the data floor. But it is still, in a CI/CD tool chain, it is still a process in which you can make choices about it, and those changes are then approved. And if any unapproved change is made, it gets reverted back to the known good state. So the way to do this is automated remediation. The way our product works, we can go and scan your existing cloud environment, and we auto-generate a definition of that infrastructure. And then any unauthorized changes from that are automatically reverted to that known good state. But of course, we can also run it in monitoring only mode. So I think what I'm trying to get to here, and it's tough when you get asked, go up and talk about the problem you're solving, but don't give a pitch. So I'm trying really hard not to give a pitch. But the problem is one of exploding complexity on the cloud, one of growth in the cloud. Every time you add something, it's going to get worse. And as those pile up, your team probably isn't going to grow fast enough to keep up with it, if it ever was keeping up with it. So our approach to this is to express all of policy and infrastructure configuration as code. We vend libraries. I mentioned we have NIST 800-53, GDPR, and others. You can also create your own policy as code. So you scan the environment, you apply the content libraries. We can generate reports listing those violations, and then establish and maintain a known good state. So what we're really talking about is kind of fire and forget cloud infrastructure. You can just build it, you can know in advance if it's correct, and once it's running, unless Fugue is yelling at you, it is still correct. So I won't read the slide, but let's see, I'm 12 minutes in. So if anyone has any questions or challenges to anything I said, fire away. Yes, please.
Are you a musician?
Am I a musician? I'm a wannabe musician. My son is a musician. But yes, the name of the company, Fugue, is based on a musical, it is a musical term, yes. Yes?
When you found unauthorized changes, what was the root cause? Was it like unintended errors or malicious people doing things?
Oh boy, it's all the above. Actually, the most common cause we see are when you have a cloud deployment, very often there are more than one team involved in that. There's the ops or DevOps team, and often they're laying down some infrastructure, and then they're saying, okay, application team, here's your infrastructure, go make your app work. And very often that's when things go off the rails, is when the app team goes in and says, well, you know, I need to SSH into that box to fix something, and then they leave the SSH port open or something like this. But certainly the other big one really is, let's just talk about, so S3 is a simple storage service. It's just a way to, it's probably half of the web is hosted on this service on AWS called S3. It's a buckets of content. Because of all the features of S3, just to pick one out of 120 services, because of all the features of it, it's used in so many use cases, it's really hard for people to know if they got it right. And I would say those are the two primary cases. Are, go try to hire an AWS expert these days. It's not easy, and even people who worked there like me and have been using it for 8 years, every year there are new features, and I might not notice that, oh, look, Aurora now has natively, or DynamoDB now has natively encrypted tables. I need to go back to the 237 DynamoDB tables I ever created and turn encryption on. So there is a broad range of issues, I'd say, but those are big ones. And yeah, bad guys getting in, that too. Please.
Does Fugue also work with a virtual private cloud, or is it going to be only with an AWS or Azure community clouds?
It's a great question. So the question was, will we work with private clouds? So we work against these API surfaces. So right now, our launch platform, the product launched last year commercially. We just rolled out a major new product called Risk Manager, which is a SaaS product. You can go and take a look at that, and it'll scan your AWS environments right now and tell you if they're 800-53 compliant. So the launch platform is AWS. We're adding Azure shortly. The problem with, we will be supporting Kubernetes. The problem with private clouds for us are they're all snowflakes. So like, what software-defined network technology are you using? How much of OpenStack versus Kubernetes are you using? So the answer is, in some cases, yes, through Kubernetes and other things like that. But every private cloud is a unique animal, so it's hard for us. We can't just like support private cloud the way we can a public cloud provider. Yes?
I have a mentee who's interested in specializing in the cloud. So what advice would you relay to me to relay to him about becoming a cloud security specialist?
That's a great question. So the first thing is AWS, and I'm sure Microsoft are similar. I have an AWS bias. I came from AWS. I'm trying to get up to speed on Azure. We went and hired people from Microsoft so that we would be, us AWSers would be offset. So I know more about their educational programs. They have a ton of content leading to the various certifications online for free. That you can go through, and these are videos, tutorials. There's a free tier. I'm sure the same is true in Azure. So I would say if you're interested in becoming a security expert on cloud, pick one cloud to start with. I believe all three of the big ones have a security certification path as part of the practitioner path. And I would look at the coursework for gaining that certification. And those certifications are gold right now in the market. You know, people are really desperate for cloud talent. Any other questions for me? Please.
I've got one. So it sounds like, so we went from a world where there was cookie cutter, sort of server-based, iron-based things to these snowflakes, to networks of snowflakes. How does the squirrel keep track of how she buried the nuts? In terms of does your product help document why you made these things? You mentioned 230 instances of Aurora or whatever. How do we keep track of that?
Oh, I love that question. Yeah, so the way Fugue approaches it is we allow you to organize collections of cloud into what we call processes or environments. And then every minute, we're looking at every configuration item on everything in that environment. And if anything changes, we're telling you, and we're keeping a log of everything that ever happened. So this way, rather than going all over the AWS console or the Azure console, looking for, you know, as you say, all the nuts the squirrel buried wherever, when those get made, they are registered into what's effectively a live configuration management database that's constantly being updated. So you can just ask Fugue, what's the state of this collection of stuff, and it will tell you. And it will even play it back over time. So, but that is a hard problem, and it's one of the